Hi everyone, in this video we are going to be talking about exponential functions. So an exponential function is a function in which the variable is in the exponent. So if we have f of x equals b to the x, we say that that's an exponential function as long as b is some constant, so some number, b is positive, and b can't equal 1, because if b were negative, remember negative numbers with exponents behave differently, because if we have a negative to an even or a negative to an odd, that is actually going to change the sign or not. And then we don't count 1 either, because 1 to any power is just 1, so that doesn't really help us too much. Okay, so on the left we have examples of exponential functions. So 2 to the x, 1/3 to the negative x, negative 6 to the 2x plus 1. All of those are exponential functions because the x is in the exponent. The ones on the right are not exponential functions. The first one's obvious because, well, the x isn't in the exponent. The second one, the base is negative, so that one's not an exponential function either. In the third one, we do have x in an exponent. Remember, the base needed to be a constant, meaning a number, and not x itself. So that one's not going to be exponential either. Okay, so to start off, we're just going to evaluate some of these exponential functions. Hopefully get a nice little reminder of how some exponents work. So if we want to evaluate 4 to the x for f of 2, we just plug the 2 in, so we get 4 squared is 16. Hopefully that one's nice and straightforward. For the next one, if we have 4 to the 1/2, 1/2 means it's actually the square root of 4, which would be 2. And then one more I'm actually going to add into this is f of -3. So f of -3 would be 4 to the -3. And just as a reminder, with negative exponents, that means we're really flipping it into a fraction. So this would be the same as 1/4 to the third. 4 to the third is 64, so 1/64 would be our answer. Okay, let's try some more on a different one. So 5 to the x minus 1 for g of 3. So we plug in 3. It's going to be 5 to the 3 minus 1, which is 5 squared, which is 25. 5 to the 0 minus 1 is going to be 5 to the -1, which, remember, just flip it upside down. So that'd be 1/5 to the first, or just 5. So 1/5 would be our answer for that one. All right, last one, example 3, 16 to the x for h of 3/4. So we're going to plug in the 3/4. If we plug in the 3/4, remember, top is the power, bottom is the root. So we can really think of this as the 4th root of 16 cubed. 4th root of 16 is 2, and 2 cubed is 8. Okay, hopefully that was a bit of a review. But now let's go ahead and go on to graphing exponential functions. So, like usual, we're going to start out by just plugging in some x values and seeing what happens. So we're going to plug in -2, -1, 0, 1, and 2. So go ahead and pause the video, try plugging all these in, make sure you're okay with all of these. Also, as one little reminder, any number to the 0th power is 1. So don't forget that rule. But plug these in, and you will see the answers in a few seconds. Okay, so if we plug them in, here are all the y values we would get. So let's go ahead and put these on the graph. So -2, 1/4, be right about here. -1, 1/2, 0, 1, 1, 2, and 2, 4. All right, if we go ahead and draw this shape, we can see that it's getting really small, but it's not actually touching 0 on the left side. So that means we actually have an asymptote right here. Because we can't raise 2 to any power to make it 0. So we're never going to touch that, so it's going to get really close to the asymptote, and then it's going to go up really, really fast. Right? And this is to the x. So it gets really close to an asymptote at the bottom, and then goes up really fast towards the right. All right, if we look at the domain and range, domain is -infinity to infinity. Range would be 0 to infinity. And our horizontal asymptote is at y equals 0. All right, let's go ahead and move on to another one. Again, we're going to start by just plugging in some numbers. Except for this time, we're not going to plug in all of those numbers. Since we see the basic idea of the shape, I'm just going to go ahead and plug in -1, 0, and 1. All right, again, go ahead and plug these in, see what you come up with. The answer will be popping up in a few seconds. All right, so here are the y values that would go with it. And again, for all these y values, you can just use your calculator. It's no big deal. But in a minute, we're going to be going away from just plugging in values to see what happens anyway. All right, so let's go ahead and plot these. So we got -1, 3, 0, 1, 1, 1/3. Again, we're going to have that horizontal asymptote right on the x-axis. And it's going to make a very similar shape. The difference this time is that it's going to be dropping as we go to the right. All right, so let's go ahead and look at domain, range, and horizontal asymptote again. Domain still -infinity to infinity. Range is 0 to infinity. And the horizontal asymptote is at y equals 0. Okay, so now let's go ahead and look at some basic properties of these functions. That way we can start graphing them a little bit easier than just plugging in points every time. So here is kind of your cheat sheet for exponential functions. Here's everything you need to know to be able to graph them. So if we have b to the x, and again, b has to be greater than 0, b can't be 1, as long as we have that, then our 3 points that we're going to graph are going to be 0, 1, 1, comma, whatever the base is, and -1, comma, 1 over that base. So flip it upside down. So if we go back up real quick to our examples before, you can see both of them had 0, 1, because anything to the 0th power is 1, doesn't matter the base. Then we also had 1 comma that base, so 1, 2 for 2 to the x, or 1, 1/3 for 1/3 to the x, because anything to the first power is just itself. Lastly, -1 is the other easy one to do because it just means to flip it upside down. So we had -1, 1/2 and -1, 3, just from flipping that base upside down. All right, so those are the 3 points that we're going to be working with. Our domain is always going to be -infinity to infinity, and our range is always going to be 0 to infinity because we're always going to have that horizontal asymptote right at y equals 0. Now, keep in mind, this is for a parent graph of an exponential function, so if we start moving this around, then that range and that horizontal asymptote may actually change. But for the parent function, these will always be true. Next up, if b is greater than 1, then f of x is going to be increasing. If it's between 0 and 1, it's going to be decreasing. So again, we can see that we had 2, that was bigger than 1, so from left to right, this graph was increasing. Then we had 1/3, which was between 0 and 1, and from left to right, this graph was decreasing. So that gives you a basic shape to start with. Then we're going to use the same exact transformations that we've been using to be able to move this graph around. So all of those same transformations of going up, down, left, right, and reflecting are still going to be there. Just keep in mind, whenever something is with x inside of the function, in these, that just means that it's going to be in the exponent with x. So like if you have x plus 5, and that is all in the exponent, then that would be left 5. All right, so let's go ahead and try some and start moving them around and seeing what happens. All right, so to start off, we have 3 to the x minus 2. So we're always going to start by just graphing the parent function, which in this case would be 3 to the x. So if we go over our 3 different points that we know we're going to have, 0, 1 is always the first one. 1 comma our base is 3, so we're going to have 1 comma 3. And then -1 comma 1 over our base. In this case, that would be 1/3. So let's go ahead and put these on the graph. Go ahead and graph our parent function. So we got 0, 1, 1, 3, -1, 1/3. And we also know that we're going to have an asymptote at y equals 0. So we're going to go ahead and put that down as well. So here is our parent graph. All right, once we have that, we are just going to use the transformations to move it around wherever we need to. In this case, we have x minus 2, and that minus 2 is with the x. So that means it's left to right. And remember, for left to right, we always do the opposite of what we would think. So minus 2 would usually mean left, but in this context, it means right. So this means right 2. So all I'm going to do is take each one of these points and move them to the right 2. Now, if we're moving left or right, the asymptote is actually not going to change at all. Because even if I move this asymptote to the right 2, well, it's horizontal, so moving it to the right 2, it would still be in the exact same place. So we don't have to worry about moving the asymptote. We get to just draw our new graph. and that would be our graph for it. All right, so for domain, it's negative infinity to infinity. Our range didn't change because our asymptote didn't change. So that's going to be 0 to infinity. And our horizontal asymptote is still at y equals 0. Okay, so now let's look at one where our asymptote is going to change. So again, we're going to start out by graphing the parent graph. In this case, it's also 3 to the x, which we've already done on the left. So I'm going to go ahead and just plot those same points and go ahead and get our parent graph drawn. All right, in this case though, we have a +3, and notice it's not in the exponent. If it's not in the exponent, that means vertical. So this is going to be going up 3. So each of these points, I'm just going to move up 3. And this time, we are actually going to move the asymptote, because while moving something left and right on an asymptote still just puts it right back on the asymptote and it doesn't do anything, if we move it up or down, that is going to move the whole asymptote. So our new asymptote is going to be up 3. And then we can go ahead and draw our graph. Our domain is going to be negative infinity to infinity still. Our range this time is going to be 3 to infinity, because 3 is now the lowest it goes. And our horizontal asymptote is now at y equals 3. All right, our next example. We have 2 to the negative x minus 3. So again, we're going to start off by doing 2 to the x, because that's going to be our parent graph. So we're going to graph that first. So if we want our points for it, they're going to be 0, 1, 1 comma the base, which in this case is 2, and then negative 1 comma 1 over the base, so 1 half. All right, so let's put our asymptote. Put our points. And then we can go ahead and draw our graph. All right, this time we have a couple different things that are being done to it. We have a negative with the x, and then we have a minus 3 at the end. So we're going to do this in a couple steps. So first off, the negative that's with the x, that's going to be a reflection. And in particular, since it's with x, that's going to be a reflection over the y-axis. So it's a left to right reflection. Right? So think of the y-axis as a mirror, and anything that's to the right one is going to be to the left one. Anything that's to the left one is going to be to the right one. And it's going to end up looking something like this. That's the reflection. Now keep in mind, we're not done yet though, because we still have that minus 3 at the end. That would go down 3. So we're going to take each of those points and we're going to move them down 3. And keep in mind, since this is moving downwards, the asymptote is actually going to move with us this time. I'm going to use a different color for that, just so we can see the difference. Again, once we're here, we can go ahead and just draw our graph through those points, making sure that we hug that asymptote to the right. All right, domain, negative infinity to infinity. Range, -3 is now the lowest it goes, so -3 to infinity. And then our horizontal asymptote is at y equals -3. All right, let's try another one with a reflection. So luckily this parent is still 2 to the x. We already did that to the left, so let's go ahead and copy those back down. And go ahead and draw our parent graph. All right, this time, the negative is not with the x. The negative is in front of the whole function. It's in front of the whole 2 to the x. That is still a reflection, but this time it's going to be a reflection over the x-axis. This is going to be a vertical reflection. So again, same idea of the mirror, but this time it's going to make it point downwards. Our asymptote is on the mirror in this case, so we don't have to reflect that at all, because it wouldn't do anything. Instead, our asymptote just stays there, and we can go ahead and draw our new graph. All right, domain, still negative infinity to infinity. Hopefully everybody's catching on that all of these are going to be negative infinity to infinity for domain. The range, though, this time we don't have a minimum, we have a maximum. So negative infinity is how far down it goes, but it only goes up to 0 this time. And our horizontal asymptote is still y equals 0. All right, 2 more examples. So for example 10, this is just a parent graph. So we're not even going to have to move anything around. We're just going to be graphing 1/2 to the x. So our points are going to be 0, 1, 1, 1/2, and -1, 2. Again, 1, the base, and -1, 1 over the base. So flip it upside down. And let's go ahead and put our asymptote and graph it. Got 0, 1, 1, 1/2, -1, 2. And it'll look something like that. Our domain is negative infinity to infinity. Range is 0 to infinity. And our horizontal asymptote is at y equals 0. All right, for 11, luckily the parent graph is the same. So let's go ahead and put that on there. Always like having the parent graph on there. Makes it nice and easy to move all those points. Okay, so again, that's just me copying it down from those same points on the left. This time, we have a couple different translations that we're going to be doing. We have a plus 3 that's with the x. So that means we're going to go left 3. And then we also have plus 1 on the end, which means we're going to go up 1. So for each of these points, we're going to go left 3 and up 1. Now for our asymptote, the left 3 doesn't do anything, but the up 1 does. So our asymptote is actually going to move up 1. Once we have that, we can go ahead and draw our graph and we're good to go. For domain, negative infinity to infinity. Range, our bottom is now 1, so 1 to infinity. And our horizontal asymptote is at y equals 1 now. All right, and with that, that is all for graphing the exponential functions. In the next video, we're going to talk a little bit about applications of exponential functions. So I will see you in that video.